Today, we're going to pull back the curtain on the AI that makes our incredibly complex world of instant delivery actually work. It's a technology called neural combinatorial optimization. And trust me, it's the secret sauce that's completely changing the game in modern logistics.
I mean, it really does feel like magic, doesn't it? You click a button and poof, a day or two later, there's a box on your porch. But behind that simple, everyday miracle is one of the most ridiculously complex logistical puzzles ever created. And solving it is a massive, global challenge.
So let's really try to wrap our heads around the scale of this puzzle. Because the world of e-commerce and global supply chains, well, it operates on a level of complexity that is genuinely hard to fathom.
Okay, just picture a single warehouse, right? Now fill it with millions of different items. Then imagine thousands of trucks, planes, and ships all heading to a near infinite number of destinations. For every single package, there's an astronomical number of possible routes and combinations. And yet, in the middle of all that chaos, the goal is actually pretty simple. Businesses just need to find that one single best way to get everything from point A to point B, balancing the lowest possible cost with the fastest possible speed. The real question is, how on earth do you even start to solve a problem that huge?
Well, for decades, mathematicians and computer scientists have used a pretty classic approach to crack these kinds of codes. It's a whole field of study with a very, very fitting name.
It's called combinatorial optimization. The classic example you always hear about is the traveling salesman problem. A salesman has to visit a bunch of cities and wants to find the absolute shortest route that hits every single one without backtracking. CO is the math that helps you find that one perfect path out of all the possibilities.
But, and this is a huge but, there's a catch. When you scale up from a handful of cities to millions of packages, the number of possible routes doesn't just get bigger, it explodes. It grows exponentially. Trying to use those classic CO methods to find the perfect solution for a modern delivery network would take, well, it would literally take longer than the age of the universe. It's just completely impractical.
So, if the old-school methods can't possibly keep up, we need a totally new way of thinking. And this is exactly where a really powerful type of AI comes into the picture. One that doesn't just follow a set of instructions, but one that actually learns and thinks for itself.
We're talking about reinforcement learning, or RL for short. The best way to think about it is like teaching an AI to play a video game. The AI, or the agent, makes a move. If that move leads to a high score, it gets a reward. If it messes up, it gets nothing. It does this over and over, millions of times, learning the best strategies to win the game, all through pure trial and error.
And this diagram here shows that exact learning loop in action. You see the agent, that's our AI, it takes an action in the environment, say choosing a delivery route. Then it gets feedback, a reward for a smart choice, or maybe a penalty for a bad one. It learns from that reward, tweaks its strategy, and then it tries again. This cycle repeats millions of times, with the AI getting a tiny bit smarter with every single try.
So what happens when you take this massive, impossibly complex puzzle of combinatorial optimization and you team it up with the incredible self-learning power of reinforcement learning? Well, you get what I like to call a true AI power couple. Now, to really get why this combination is so revolutionary, you have to compare RL to another type of AI, supervised learning. Think of supervised learning like studying for a test with the answer key right in front of you. You need a huge data set of perfect, pre-solved problems to learn from. But for our logistics puzzle, we just established that getting those perfect answers is pretty much impossible. Reinforcement learning, on the other hand, doesn't need an answer key. It learns by playing the game of logistics itself, basically creating its own data as it goes along.
And this is how it all fits together. We use deep neural networks, that's the neural part, to give the AI a powerful pattern-spotting brain. We use reinforcement learning, the RL part, to teach that brain how to solve problems through that trial and error process. And the problem it's solving? Combinatorial optimization, the CO. Put it all together and you get neural combinatorial optimization with reinforcement learning, or NCO-RL.
And the benefits here are just enormous. This is the big breakthrough. It turns a problem that would take a supercomputer a billion years into something that can be solved in, say, an afternoon. NCO-RL finds that perfect sweet spot between a high-quality solution and a fast one. It learns without needing an answer key, it can adapt on the fly to real-world chaos like traffic jams, and it finds incredibly good solutions in a practical amount of time, not an eternity.
Okay, so this all sounds amazing in theory, but where is this tech actually being used? Let's look at how NCORL is being put to work right now, out in the real world.
And I mean right now, this isn't science fiction. NCORL is one of the core engines of what we call Industry 4.0. That's the fourth industrial revolution, where everything in manufacturing and logistics is being totally transformed by smart, connected, data-driven tech. This AI is what's making our supply chains intelligent.
And you can see its applications basically everywhere. Finding the most efficient routes for an entire fleet of delivery trucks? That's vehicle routing, powered by NCORL. Trying to figure out the absolute best way to pack thousands of different sized boxes into a single shipping container? That's called bin packing. From scheduling factory floors to assigning tasks to workers, NCORL is the optimization engine running behind the scenes.
But the story doesn't just stop at making things faster and cheaper. Nope. The next evolution of this technology is already coming into view, and it has a very different set of goals in mind.
Researchers are already talking about the next phase, Industry 5.0. And here, the main goal isn't just about pure cold efficiency. It's about using this incredible optimization power to build systems that are better for the planet, that are more resilient to shocks and disruptions, and that are ultimately designed to work better for people.
And this isn't just some feel-good, wishful thinking. As this quote from the research makes clear, the potential for NCORL to tackle these much bigger challenges, like sustainability and our own well-being, is already being proven out. The same AI that optimizes package delivery could one day help optimize for a greener, more stable world.
Which really brings us to the final big thought here. We are building these unbelievably powerful tools that can find the best solution to almost any problem you can throw at them. So the crucial question we all have to answer now is, what do we define as best? As this AI continues to optimize our world, the real challenge is going to be making sure it's optimizing for the right things, for us. Thanks for joining me.